Okay, we have an application of the ideal gas law where we're solving for some gases and really looking at the chemistry here. And we're talking about nitroglycerin, this explosive substance here that we're given the decomposition products of this in our problem right here. Okay, so we're given that, and we need to find out if everything goes right, we need to calculate the mass of nitroglycerin that must have reacted based upon this volume of carbon dioxide that was produced at this temperature, and it's nice that they give us 1 atmosphere. Just a little bit for that. So first thing we need to do is make sure we get the chemistry right. And so we have nitroglycerin, so we have C3H5NO3 that is going to decompose. It's going to be explosive, and it's going to decompose into these gases of nitrogen, and we know we're going to get some oxygen out of that, it tells us. We're also going to get some water vapor out of that. These are all gases, and we're going to get carbon dioxide out of that. And again, these are all gases, gases, gases. Okay, well, we got to get the chemistry right. If we're going to do that, we got to balance things. And so if we just go through and balance, we'll find there's going to be a 4, and there's going to be a 6 nitrogen, there's going to be 10 of the water vapor, and there's going to be 12 of the carbon dioxide. All right, so we need to get a balanced equation. That's crucial for that. And in fact, it tells us that that's our first step right there in our ALEKS problem. So let's make sure that we get this this balanced correctly, because that's going to be everything that we need. Okay, so it tells us that when we do this reaction, we get 81 liters of carbon dioxide in here at a certain pressure and temperature. Well, we know from the ideal gas law that PV equals nRT. Now it's asking for the mass of nitroglycerin that was consumed in grams. Well, we don't have mass, we're actually given CO2. But from our carbon dioxide, we can use our stoichiometry to get at the nitroglycerin that was going to be consumed. And so I have a pressure of 1 atmosphere. I have a volume of 81 liters. I know R. It gives me a temperature in degrees Celsius, so we'll have to convert that into degrees Kelvin. And then now I can solve for N, which is the number of moles of CO2. And so I have N that's going to equal to PV over RT. Okay, so let's just do the one conversion that we have to do here. So I have minus 15 degrees C. If I convert that into Kelvin, 273.15, then that should give me 258.15 degrees C. All right, so let's plug everything in here. So N equals pressure is 1 atmosphere times 81 liters divided by R, 0.08206, times our temperature, 258.15 degrees. That's in Kelvin. Okay, so for the number of moles, when I do this, I get 3.8278 moles. Now we know sig figs are going to come into play there, and we need to keep those in mind. So I am seeing 3 sig figs so far. Okay, and so that is going to be the moles of CO2. Okay, so I have 3.8278, and again I got those 3 sig figs, moles of CO2. All right, we just used the ideal gas law to get that. Well, we know from our chemistry here that for every 12 moles of CO2 that are generated, I'm going to consume 4 moles of the of the C3H5NO3. Okay, so my nitroglycerin right there. And if I calculate the molar mass of this, I know that in every 1 mole of nitroglycerin, I'm just going to write nitro, then I calculated that there are 227 grams in 1 mole of nitroglycerin. Okay, so if I do that, then I get out of this, including sig figs, that there are 289 grams of nitroglycerin that were consumed, which is what's being asked here. Okay, so what's my strategy here? Number one, get the chemistry right. Balance it properly. Try to do it by yourself because you'll have to on a test. Every now and then you can kind of look up how to balance on Google or something like that if you don't want to spend all that time, but it's good practice for you so you can do that on a test. Once you get this down, the correct chemistry, then we use our ideal gas law. Make sure we get things right into the right units. Pressure is going to be in atmospheres. Volume is going to be in liters. N is the number of moles. And T is temperature. So out of this, I can get the number of moles of carbon dioxide, of CO2 that comes out of this reaction. And it's asking, well, how much in terms of grams of nitroglycerin must have been consumed by that? Well, I can use my stoichiometry. For every 12 moles of CO2 that is generated, I consume 4 moles of the nitroglycerin, which is what we did down here. All right, so these are doable. It's just an application of the ideal gas law, as well as some of the previous stuff that we've learned in terms of stoichiometry. So I think if you're careful, actually these are not terribly difficult to do, and you should be able to do it.